Hello everyone and welcome back to the Don't Have channel. In today's video, we will be diving into the world of feature relevance and feature selection in machine learning. Specifically, we will be using mean decrease impurity and variance threshold. Before we jump into the coding, let's briefly talk about feature engineering. Let's get started. Feature engineering is a crucial step in machine learning pipeline. It involves selecting, modifying, and creating new features to improve the model's performance. Today, we will be exploring two key techniques, which is the mean decrease impurity for feature relevance and variance threshold for feature selection. So let's start with the mean decrease impurity. It's a technique we use to determine the importance of features in decision tree or random forest. Alright, so we are going to first start by importing the necessary or required libraries, which includes NumPy, Pandas, PyPlot, train test plates, decision tree classifier, and then make decision or make classification. So I'm just going to run it, okay? Okay, so once we've been able to import the libraries, the next step is I'm going to create a synthetic data, okay? You can load your data set if you want, but I'm just going to create a synthetic data for demonstration purpose, okay? And what I'm basically doing here is I've specified I want 100 samples, number of features to be 5, okay? Number of informative 3, redundant 0, and then random state 42, okay? And I'm just going to run this as well, okay? So currently we have our x and y, which is our features values, and then or our independent variables, and then we have y, which is our dependent variable. So I'm just going to print y2. So as you can see, they are just variables, okay? So the next thing is to create feature or feature names for them, okay? And what I'm basically doing here is giving the features or the values feature names, okay? So feature 0, feature 1, feature 2 in that order. And once I'm done, I'll create a data frame for that by passing the x, okay? And then once I do that, I will now add the target variable by passing y as well, okay? So let's just run this. I hope you will now understand it by printing the data, okay? Right, so now we have our data frame. Then we have feature 1, feature 0, 1, 2, 3, 4 in that order, okay? And we have our target variables as well, right? So now our data set is ready, okay? But mind you, if you imported your data or your data set, you won't go through this, okay? We just load your data set, and then from here onwards you'll be ready to go, okay? So the next thing is to split our data into features and targets, okay? And I'm just going to do that by running this. And then next step is to split our data into training and testing. So 20% for testing, 80% for training. That's what we are basically doing here. We are using the train test plate, okay? And I'm going to run that as well. So now we have our X train, we have our Y train, okay? Yeah, so before then, here when you check here, we have 100 rows, right? But here we have 80 because we are using 80% for training, okay? So you can now, let me cut this one. Okay. Now we move on to training the model. So we are going to call the model or initialize the model. We are going to fit the model with a training value for x and y, okay? Right. So once we are done fitting it, decision tree classifier gives or provides a function, okay, or a property where we can know the features or the importance of the features, okay? So we are just going to extract that into a variable called feature importance, and then we are going to plot it, okay, so that we could know. So let's just run this one as well. And as you can see here, we have a bar chart showing the feature importance, okay? And as you can see, feature 0 seems to be more important than the rest, okay? And it's quite, the gap is quite huge, right? Followed by feature 2, feature 4, feature 3, and feature 1, okay? So from this we could tell that feature 1 is less important because it has the minimum value, right? Yeah. So that is it for the mean decrease impurity. Next, we will move on to the variance threshold. Okay, so this one too is a technique for selecting features. Okay, and it provides, here you just provide your threshold. Okay, and we consider data set or features with less variance, less informative. Okay, in that manner, less important. So you set a threshold, and all the features below that threshold you can drop them. Okay, which we consider them as less informative. So that's the techniques or the idea behind the variance threshold technique. And that one too, we are just going to import the necessary libraries, which we've already done. Okay, and I'm going to create a data frame again. So it's basically the same thing as we did earlier on. Create the features. Okay, split them into training and testing as well. Okay, so from here, that is, we are going to set a threshold. So we are setting all features less than 0.1, we should drop them. Okay, and then we are using the variance threshold. We are passing the threshold. So we got that function from feature selection from sklearn. Okay, and then that, yeah, so we just fit our model, fit transform. Okay, we pass in the training. So I'm just going to run that as well. Okay, and then we are getting support. Okay, so you get the selected features indices. So I'm just going to run that one as well. We are also going to get the columns as well. So I'm just going to run that. So from the indices, we are going to get the x columns, and we are going to plot that one as well. So I'm just going to plot that. And as you can see, it didn't drop any of them, meaning all of them had feature relevance greater than 0.1. Okay, but again, as you can see, feature 0 has more informative, or is more informative, right? Yeah, so let me try and see. Okay, let's make the threshold 1. Okay, so let me just go back again, run this again. Wait, let me run this one as well. Great, so here we've been able to eliminate feature 1. Okay, because it had a variance threshold which is less than 1. Okay, yeah, so I hope now you get the whole idea about feature engineering. Okay, one may ask, how can I apply this in practical scenarios? Okay, so imagine you have a data set which has numerous or large number of columns. Okay, so let's say 100, 200, and all that. Okay, mind you, the larger your number of columns, the lower or how your model find it's very difficult to kind of perform well. Okay, or kind of find the patterns in the data set. So the higher your columns in terms of numbers, the lesser the performance of your model. Okay, so in order to improve your model's performance, you have to perform feature engineering, in this case dimensionality reduction, to reduce the columns numbers. Okay, so once you reduce it, it increases the performance of the model. And once you are reducing it, you don't want to lose informations. Okay, in and you can do that by first knowing the most informative features, or the features that are very, very important. So you maintain them and then drop the ones that are less important. Okay, so that is the whole idea about feature engineering. And I hope this video you really enjoyed it. If you did, kindly click on the subscribe button, like this video, share with friends, and see you in the next one. Happy coding.